Hello everyone. Welcome back. Today we have an exciting video in store for you. We're going to solve 5 Python problems with the help of ChatGPT, a powerful AI language model. So let's get started. Our first problem is FizzBuzz. Write a program that prints the numbers from 1 to 100. But for multiples of 3, print fizz instead of the number, and for the multiples of 5, print buzz. For numbers that are multiples of both 3 and 5, print FizzBuzz. We'll start it by defining a for loop to set a range between numbers 1 to 101. For I in range 1, 101. If I divisible by 3 double equals to 0, and I divisible by 5 double equals to 0. Then, print fizz buzz. Now do same thing for next 2 steps. I will explain you this after the code. The first line sets up a for loop that iterates through numbers from 1 to 100. The range function generates a sequence of numbers starting from 1 and ending at 100, but not including 100. The second line checks if the current value of I is both divisible by 3 and divisible by 5. If I satisfies both conditions, it prints FizzBuzz. The third line checks if the condition in the previous if statement is not met. This elif, short for else if, line checks if the current value of I is divisible by 3. If I is a multiple of 3, but not a multiple of 5, it prints fizz. The fourth line checks if neither of the 2 previous conditions is met. This elif line checks if the current value of I is divisible by 5. If I is a multiple of 5, but not a multiple of 3, it prints buzz. And the last line checks if none of the above conditions are met, this else statement is executed. And it simply prints the current value of I. This is a classic example of the FizzBuzz problem, often used in coding interviews to test a candidate's ability to use conditional statements and loops. The next problem is Palindrome Checker. Create a program that checks if a given word or phrase is a palindrome. A palindrome is a word, phrase, number, or other sequence of characters that reads the same forward and backward. We'll start by defining a string that takes user input. S equals input. Enter a word. Lower, this will convert all characters into lowercase. If s, now we will reverse the word at index ::-1 is equals to the actual string. Then print true. Else print false. Hope you understand. Let's run this code. Enter a word, let's say level, it will return true. Again, let's say Python, so it returns false because Python is not a palindrome. The next problem is Factorial Calculator. Write a function that calculates the factorial of a given number. The factorial of a non-negative integer n, denoted as n!, is the product of all positive integers less than or equal to n. We'll start by defining a function called factorial. Give it to a parameter n. If n is equal to 0 or n equals to 1, then return 1. Else return n into factorial of n minus 1. Print factorial of 5. Here's the explanation. The base case is checked using the condition if n equals 0 or n equals 1. If n is either 0 or 1, the function returns 1. This is because the factorial of 0 and 1 is defined as 1. If n is not 0 or 1, i.e., it's a positive integer greater than 1, the else block is executed. In the else block, the function calculates the factorial by recursively calling itself with the argument n1 and multiplying the result by n. This is the essence of the recursive algorithm for calculating factorials. For example, if you call factorial of 5, it will calculate 5 into factorial of 4. Then, factorial of 4 will calculate 4 into factorial of 3. This process continues until factorial 1 is reached, at which point it returns 1. Then, the calculations are unwound and multiplied together 1 into 2 into 3 into 4 into 5, which gives you the factorial of 5. This recursive approach is a common way to calculate factorials, but it's important to note that it can lead to stack overflow errors for very large values of n due to the recursive function calls. The next problem is prime number generator. Write a program that generates a list of prime numbers within a given range. A prime number is a positive integer greater than 1 that has no positive integer divisors other than 1 and itself. We'll start it by defining a for loop. For I in range, let's say 1 to 101. I wrote 101 because for loops count 1 also. Count equals 0. For j in range 1, I plus 1. If I mod j is equals to 0, then count equals count plus 1. Outside the for loop, if count equals to 2, then print I end equals empty space. Here's the explanation. The outer for loop iterates through numbers from 1 to 100 using the range function. Inside the outer loop, a variable count is initialized to 0. This variable will be used to count the number of factors, divisors, of the current number I. The inner for loop iterates through numbers from 1 to I. It checks each number j to see if it's divisor of I. Inside the inner loop, there's an if condition that checks if I is divisible by j with no remainder. If this condition is true, it means that j is a factor of I, so the count variable is increment by 1. After the inner loop finishes, the count variable holds the count of factors of I. If count is equal to 2, it means that I has exactly 2 factors 1 and itself, which is a characteristic of prime numbers. So, the code checks if count equals 2, and if this condition is true, it prints the value of I using print I. The end argument is used to print the numbers on the same line with a space between them. The outer loop continues to the next number, and the process repeats for each number from 1 to 100. As a result, this code will print all prime numbers between 1 and 100, separated by spaces. Prime numbers are those numbers that have exactly 2 divisors, 1 in themselves. So, the count variable is used to determine whether a number is prime by checking if it equals 2. The next problem is word frequency counter. Create a program that takes a text document as input and counts the frequency of each word in the document, ignore punctuation and convert all words to lowercase. Then, display the words and their frequencies in descending order. But I will teach you only how to count the frequency of each word in document because I didn't teach you advanced Python yet. We'll start by defining a user input that takes a text document. Text equals input. Enter. Sum. Text. For I in text. Print. Text. Dot. Count. I, I. Let's run this, enter some text. Type anything. As you can see, it returns the frequency of each letter and that letter. Here's the explanation. The first line starts a for loop that iterates over each character in the text string one by one. The variable I represents the current character being processed. Inside the loop, this line prints 2 pieces of information. Text.count of I. This part of the code counts the number of occurrences of the current character I in the entire text string using the count method of strings. It returns the count as an integer. I is the current character being processed in the loop. Hope you understand. If you found this video helpful, give it a thumbs up, subscribe for more coding tutorials, and ring that notification bell. Happy coding, and I'll catch you in the next video. Thanks for watching. Bye.